Hello students, continuing in the chapter of alternating currents. In the second lecture today, let us discuss some of the series circuits and the phenomenon of resonance. In the last lecture, we have already discussed that EMF, current and various resistance elements such as resistors, inductors and capacitors, they can be treated as vectors. So in this lecture, we will be having the recapitulation of all those concepts which we discussed and the application of that in various series circuits. As a first example, let us discuss series If you remember, we have already discussed LR circuit in case of a constant voltage applied to these two elements. But in our today's discussion of LR circuit, we are applying an alternating EMF to series connection of resistor and inductor. Imagine that the resistance value is R, and in series with this you have an inductor connected, and both these together they have been connected to an alternating EMF source. Say EMF is E naught sine omega t. If you remember, this E naught was the peak value of EMF and omega was the angular frequency. Now, if you remember that we have expressed these things in phasor diagrams. For solving this kind of circuit, your aim is to find out the value of current which is flowing in this series LR circuit. Purposely we are not showing the direction of current, because you remember in alternating currents the current direction is all the time changing, the magnitude is also changing. So I have just expressed I without showing any particular direction. Had it been circuit of constant voltage source, you can show the direction, but here you are not permitted to show the direction, and you have to find out the magnitude of the current which is flowing in this particular circuit. Now the first step happens to be to find out the equivalent resistance of this entire circuit. Of course, for calculating current you will be using Ohm's law, but for that you should know what is the total resistance existing in this particular circuit. For that you happen to form something called impedance triangle. What we mean by impedance triangle is that you have to find out the total resistance, and you know that resistance is called resistance, but the resistance offered by inductor and capacitor, they are given a name reactance, and all of them are being treated as vector quantity. Both of them together they are called impedance. So you have to express all these resistors or reactance as a vector form. For example, the resistance was expressed in horizontal direction, but the reactance of inductor, that is expressed in upward direction. So here the reactance of inductor, which I am denoting by XL, X stands for reactance, L stands for inductor, and this was having a value omega into L, which you have already derived in the last lecture. You understand? Here resistor will be treated as a vector represented in horizontal direction, and the reactance of inductor will be treated as another vector, but it will be expressed in vertically upward direction. And the total impedance of the circuit will be denoted by Z. This is the standard notation we use. Mind you that resistor, reactance, impedance, all of them have the same unit, that is called ohm. So the net impedance of the circuit will be the Pythagoras of these two values you have. You understand? So this will be simply R square plus omega L whole square under root, isn't it? If you have resistance as base and omega L as perpendicular, then the impedance value you will be getting like this. So if you want the current, then remember that just by using Ohm's law, you can simply write it as the EMF supplied upon the total impedance of the circuit. The total impedance of the circuit is the Pythagoras of these two quantities. So that becomes your formula. You understand? This is the essential formula you will be using for any of the LR circuit connected to an alternating source. Remember that if you have to find out the RMS value of current, then you will be using the RMS value of EMF. And in case you have to find out the peak value of current here, which you may call I0, then you will be using E0 here, or the peak value of EMF. That is very obvious. And this impedance does not have any peak value or RMS value. This is a fixed value if the value of omega becomes constant. Now, if you talk about the current and EMF relation, then you know that the current will always be lagging the EMF in case in the circuit you have inductor as dominant part. Let us suppose you consider this situation, then you know this phase angle will be written as phi, and if you show the current here, whatever current you will be getting out of this particular exercise, that will be lagging the EMF by phi. You understand? That will be lagging. If you feel like, you can write it as minus phi as well, so that it becomes very much obvious that the current is lagging. You understand? In case the resistor was absent, let's suppose only pure inductor was there in the circuit, then this phi value will become 90 degree and current will be lagging completely by 90 degree. But in case resistor is also present, then it will be lagging, but it will be somewhere in between 0 to 90 degree depending on what value of phi you are getting here. So this is the basic formula you will be using wherever you are coming across any particular question in which resistor and inductor is involved. So now let us take a demonstrating example in which we will be using these concepts of series LR circuit. Let us take a demonstrating example on series LR circuit. Time and again I am saying that the LR word which we are using, that should not be confused with the LR circuit we have already discussed in constant voltage source, but definitely right now we are having an example in which we will be invoking the concept of constant voltage as well. What is given to you in the question is that if you have an inductor connected to a constant voltage source of 12 volt, then it says that the current which is flowing into the circuit is equal to 2 ampere. You understand? It is given to you in the question that you have an inductor coil connected to a voltage source which is constant 12 volt, then the current which flows in the circuit is 2 ampere. But in case the same inductor is connected to an alternating source of 12 volt, for the sake of convenience take the frequency to be 50 hertz, then it is given to you that the current which is flowing here is 1 ampere. You understand? This is the question. the inductor is connected to 12 volt DC, current was found to be 2 ampere, but if it was connected to an AC, then the current was found to be 1 ampere. First you have to find out why the current changed. Why the current changed? You have to find out. Changed means when you have connected it to alternating source, why it has changed. When it was in DC, it was giving more value, but in AC, it is giving lesser value. Why? First thing, you have to find out that. And secondly, you can find the value of inductance. You understand? The inductor coil which you have connected, what is the value of inductance it is having, that you have to find out. Now understand that when you are talking about an inductor, which is a real life inductor, it will be formed out of some wire. You understand? कोई ना कोई वायर जरूर आपने यूज की होगी और तभी जाके ये इंडक्टर कॉइल बनेगा. नाउ वायर को अगर आपने सोलेनॉइड फॉर्म में बनाया है, व्हेन इट हैज बिकम एन इंडक्टर कॉइल, तो इसमें सिर्फ इंडक्टेंस नहीं है, इसके साथ साथ इसमें रेजिस्टेंस भी है. यू अंडरस्टैंड? वेन एवर यू आर फॉर्मिंग अ कॉइल आउट ऑफ सम वायर, it is not only having inductance, rather it is having some part of resistance as well. So whenever you are solving this particular circuit, then I will say that the real life inductor should not only be shown like a inductor coil, rather it should be shown as a resistor as well. You understand? What I am trying to say is that the values which were shown here, like just like an inductor, you should also keep in your mind that it is not only an inductor, rather a kind of, you can say, resistor is also included here. This is a kind of thing which is implicit. You understand? This is implicit here. आपको खुद से ये इमेजिन करना पड़ेगा कि उन्होंने अगर इंडक्टर सिर्फ कह दिया है, तो दिस इज नॉट ओनली इंडक्टर विच इज गिवन टू यू इन दिस सर्किट, रादर अ काइंड ऑफ रजिस्टर इज ऑल्सो इन्वॉल्व हियर ऑल्सो. यू शुड अंडरस्टैंड, उन्होंने आपको मेंशन नहीं किया है, बट इट इज अंडरस्टूड दैट अ रजिस्टर इज ऑल्सो इंक्लूडेड इन दिस सर्किट. दिस इज, यू हैव टू इमेजिन. You got the point? This is the idea of the question. You have to imagine this resistor, and with this imagination I am drawing this particular circuit in which inductor has been shown along with the resistor. ये resistance की value हमने खुद से assume कर ली है. Now try to remember that if you had pure inductor and pure resistor, पहले जो ये inductor उन्होंने show किया था, that was a real life inductor जिसमें कि resistor और inductance दोनों थे. So here now I have segregated both of them and I am writing it as pure inductance and writing this as pure resistance connected to a direct voltage source. Now if you remember the LR circuit along with a DC source, then you remember that the current which flows into the circuit was simply voltage what you applied upon resistance. You had seen that inductor offers infinite resistance in the beginning for a constant voltage source, but as time passes on, few milliseconds, after that the inductor stops its role and the current is a steady current. It's only due to the resistance part. So here, with this particular exercise, you can calculate that what is the value of resistance existing in this particular circuit. For example, the current for DC has been given to be 2 ampere, the voltage is 12, and the value of resistance R you can calculate. The resistance R of 6 ohm can be obtained from this particular exercise. You got it? Now imagine that you have alternating current connected to this same inductor. अब अगर आपने इंडक्टर में एक alternating current अप्लाई कर दिया है, then you see the resistance as well as inductance, both of them will be playing their role. अभी अभी आपने देखा कि अगर आप सीरीज में LR सर्किट के साथ अगर एक ऑल्टरनेटिंग वोल्टेज कनेक्ट करते हैं, देन द करंट एक्सप्रेशन, अगर आप अब इसमें एक ऑल्टरनेटिंग वोल्टेज लगाते हैं तो इसकी करंट की जो एक्सप्रेशन है, now if you see the alternating voltage is connected to this resistance and inductance, then you have used that the expression of current is 12 volt upon this R square plus omega L whole square under root. You see this? एक ऑल्टरनेटिंग सर्किट में आप देख सकते हैं कि डिनोमिनेटर की वैल्यू ज्यादा हो गई है. पहले डिनोमिनेटर की वैल्यू सिर्फ आपने रेजिस्टेंस के फॉर्म में लिखा था, बट अब डिनोमिनेटर में आप देख सकते हैं कि इंडक्टर की जो रिएक्टेंस है दैट आल्सो हैज कम इनटू पिक्चर, एंड दैट इज रिस्पॉन्सिबल फॉर द डिक्रीज इन करंट. द फर्स्ट पार्ट ऑफ द क्वेश्चन वाज दैट व्हाई द करंट हैज डिक्रीज इन ऑल्टरनेटिंग करंट. देन द रीजन इज दैट इन ऑल्टरनेटिंग करंट द इंडक्टर इज ऑल्सो प्लेइंग इट्स रोल ऑफ reactance, which was absent for the case of direct voltage source. Now if you substitute these two values, you can see, you can write it to be R square plus omega L whole square under root. This is equal to 12 upon 1. करंट की वैल्यू जो है वो आपको 1 एम्पियर अब दी गई है, so that means this is equal to 12. You understand? Now you can suitably substitute the values of resistance. जैसे resistance की वैल्यू आपने already 6 ohm calculate की है. If you see here, you have already calculated the value of resistance to be 6 ohm. Now you can substitute this expression of 6 ohm into this exercise. Then try to see what you get. You get 6 square. Understand? यहाँ पे अगर आप देखें तो यहाँ पे R की वैल्यू हमने 6 ohm substitute की है. 6 square plus omega L whole square. That makes it the square of 12. You understand? This is the thing you are getting. So you can say this omega L is coming out to be square root of 144 minus 36. Approximately you can say square root of 108. नाउ अगर क्वेश्चन में रिएक्टेंस डिमांडेड है तो आपने ओमेगा एल की वैल्यू निकाल ली है. दिस इज द वैल्यू ऑफ रिएक्टेंस यू आर हैविंग अप्रोक्सीमेटली 10 यू कैन से. एंड इन केस यू आर एक्सपेक्टेड टू कैलकुलेट द वैल्यू ऑफ एल, देन यू डिवाइड इट बाय ओमेगा. ओमेगा विल बी 2 पाई 50. अगर आप एल की वैल्यू देखें तो दिस विल बी अंडर रूट 108 अपॉन 2 पाई 50 बिकॉज फ्रीक्वेंसी इज गिवन टू यू इन द क्वेश्चन एज 50 हर्ट्ज. आप देख सकते हैं, इजंट इट? 50 हर्ट्ज दी गई है. सो ओमेगा की वैल्यू 2 पाई 50 एंड अप्रोक्सीमेटली इफ यू कैलकुलेट दिस इज अप्रोक्सीमेटली 314, दिस इज 10, अप्रोक्सीमेटली यू कैन से 33 मिली हेनरी. यू अंडरस्टैंड? 33 मिली हेनरी विल बी द वैल्यू ऑफ inductance you will be obtaining from this place. You understand? To summarize, let me tell you that whenever a direct voltage source is connected to a real life inductor, then it is the resistance part of the inductor which is playing the role, because of which the current is flowing into the circuit. But in case you are connecting it to alternating EMF, then the inductor is also playing the role, and because of which the current decreases. And with the help of, you can say, two separate equation. Here you are using current as voltage upon resistance, but in alternating source you are using current as voltage upon the total impedance of the circuit, in which resistance and reactance, both of them will be coming into picture, because of which the current is decreasing, and overall you can calculate whatever reactance or the value of inductance you want. Understand? Now once you have discovered the essential parts of series LR circuit, let us talk about series resistance and capacitance circuit, or CR circuit, or RC circuit, whatever you feel like you can call it. Now let us talk about series RC circuit or CR circuit. In alternating currents, the circuit is having alternating EMF, and that is getting subjected to resistor and capacitor. Here, say you have a resistor R connected in series with a capacitor. You have a resistor here connected in series with a capacitor, and both of them together have been connected to an alternating EMF. Let us suppose EMF is E naught sine omega t. You understand? Once again, the aim of the circuit is to find out the value of current which is flowing here. Of course, this is an alternating current which will be flowing. You have already seen such RC circuits for constant voltage sources where you have seen that the current flows for some time, but after some time the steady current is absent because capacitor offers infinite resistance to constant voltage sources. Now, once again, if you form the impedance triangle of this circuit, then you must understand that the resistance as a vector will be represented here on the horizontal line, but the reactance of capacitor will be expressed as a vector in downward direction, because that is a kind of convention you have already seen in the last lecture. The reactance has been denoted by X. Since it is for capacitance, I am denoting C, and the numerical value of this reactance of capacitor you have already seen. This is equal to 1 by omega C. You understand? So the net impedance of the circuit you will be getting here, Z, that will be essentially the Pythagoras of these two vectors which you have, and that will be written as R square plus the reactance of capacitor, that is XC whole square, and Pythagoras of these two, that is the under root of this. You understand? This is the impedance of the entire circuit you will be having. If you try to see the phase angle of this, this will be on the negative side. The phi which you are seeing here, that can be written as minus phi as well. Now, if you talk about the expression of current here, then you see essentially I will be using the expression I as EMF upon R square plus 1 by omega C whole square, or you can write it as XC whole square and the square root of this. Once again, I will tell you that in case you have to find out the RMS value or effective value of the current, then you will have to take RMS or effective value of EMF. In case you have to take the peak value of current, then you will have to take the peak value of EMF. Of course, reactance is dependent on the frequency which is given to you. Now, if you talk about the phasor diagram of EMF and current, their relative situation, then remember that if EMF as a reference is being plotted here, in this case of resistance and capacitance, where the capacitance is dominating the circuit, you will find that the current will be leading by the same angle phi. You understand here? जो आपने यहाँ पे phase angle phi दिखाई है, आप उसको minus phi भी लिख सकते हैं, and because of which the current which will be flowing in this kind of circuit, that will be leading the EMF by the phase angle phi. अगर ये सर्किट प्योर कैपेसिटर सर्किट होता तो वैसी सिचुएशन में यही फेज एंगल 90 डिग्री हो जाती, जैसे कि आपने पिछले सिचुएशन में देखा है. बट इन केस सम पार्ट ऑफ रजिस्टर इज ऑल्सो इन्वॉल्व इन द सर्किट, देन द लीडिंग एंगल will be in between 0 to 90 degree. Now, with this particular formula in mind, you can have a demonstrating example in which we will be using this, and let us have a look at that. Let us have example on series RC circuit. In a particular situation, it has been given to you that you have a box in which there is an element called X. X is unknown. आपके पास एक बॉक्स है जिसमें एक unknown element है, and once you are connecting it to 220 volt, then it has been found that the current is 0.5 एम्पियर एंड इन फेज. अंडरस्टैंड, ये आपको दिया हुआ है कि एक एलिमेंट X को अगर आप 220 वोल्ट ऑल्टरनेटिंग सोर्स से कनेक्ट करते हैं, इफ यू फील लाइक यू कैन टेक द फ्रीक्वेंसी ऑल्सो ऑफ दिस ऑल्टरनेटिंग सोर्स, दैट मेक्स इट मोर रियल. अगर आप एक एलिमेंट X को 220 वोल्ट 50 हर्ट्ज ऑल्टरनेटिंग करंट के साथ कनेक्ट करते हैं, देन इट हैज बीन फाउंड दैट द करंट विच फ्लोज in the circuit is 0.5 ampere and that current is in phase with the EMF. ये आपको given है. Now you have another element Y, which is connected to the same alternating source, 220 volt 50 hertz. You understand? Then you find that the current is, of course, 0.5 ampere, same current, but this time the current is leading. You understand? X में जब आपने वोल्टेज को कनेक्ट किया, ऑल्टरनेटिंग वोल्टेज को, तो करंट की वैल्यू 0.5 एम्पियर है एंड द करंट इज इन फेज. बट व्हेन यू आर कनेक्टिंग द सेम वोल्टेज सोर्स टू द एलिमेंट Y, then the current value is same 0.5 ampere, but this current is leading the EMF. First you have to find out what are elements X and Y. पहले आपको यह बताना है कि ये X और Y क्या हैं. And secondly you have to find out if X and Y are connected in series. If X and Y are connected in series to the same element, to the same EMF, same EMF मतलब 220 volt and 50 hertz. If X and Y are connected in series to the same EMF, then find the current. जैसे यहां इंडिविजुअली एक एक एलिमेंट में करंट 0.5 एम्पियर फ्लो कर रहा है, देन अगर दोनों को आप टुगेदर सीरीज में कनेक्ट करते हैं टू द सेम ईएमएफ सोर्स, देन व्हाट इज द करंट फ्लोइंग इन द सर्किट, यू हैव टू फाइंड आउट. ऑफ कोर्स व्हेन वी आर नॉट मेंशनिंग एनीथिंग, देन द करंट विल बी टेकन एज द आरएमएस करंट और द इफेक्टिव करंट and not peak value or something like that. Now, if you look at the entire situation, then you should understand that if the current is in phase, then we know that the element happens to be resistor. अगर करंट लैग करेगी तो वो इंडक्टर होगा, और अगर करंट लीड करेगी तो वो एक कैपेसिटर होगा. दिस इज अ फिक्स थिंग. यू अंडरस्टैंड? इन केस द करंट इज इन फेज, देन द एलिमेंट विल बी अ रेजिस्टर. फॉर एग्जाम्पल हियर एक्स में आप देख रहे हैं कि करंट इज इन फेज, then you can clearly write down in a part of the question, you must write X is a resistor. Why did you write this? Because the current is in phase with the EMF. अगर current EMF के साथ phase में है तो X एक resistor होगा, and in case in the element Y the current is leading, then Y must be a capacitor. Y is a capacitor. Now you can calculate the values of X as well as Y. अगर आप इंडिविजुअली देखेंगे तो अब हम ये कहना चाह रहे हैं कि X जो है वो रेजिस्टर हो गया, और यहां पे इसके साथ सीरीज में एक कैपेसिटर लगाओ, बिकॉज द सेकेंड पार्ट ऑफ द क्वेश्चन इज डिमांडिंग दैट now you are adding these two elements in series. That means यहां पे आप essentially resistor और capacitor को सीरीज में कनेक्ट कर रहे हैं to the same voltage source of 220 volt and 50 hertz. You understand? जब हमें यह पता चल गया कि these two elements X and Y, they are resistors and capacitor respectively, then you are adding them in series connected to the same 220 volt and 50 hertz. Now the value of R and C, that is not known to us. first you will have to find out the value of the resistance and reactance of these two elements you have connected in the circuit. You see, the value of resistance can be clearly calculated by way of Ohm's law, that is voltage upon current. In the question it has been given that the voltage you applied, that was 220 and the current was 0.5 ampere. So from that point of view, I can say this voltage is 220 and this current is 0.5 ampere. That makes it 440 ohm. जो रेजिस्टर की वैल्यू है वो आपने कैलकुलेट कर ली कि दिस इज इक्वल टू 440 ओम. On the similar line, you can also calculate the value of reactance this capacitor is offering. If I am calculating the reactance of this capacitor, this will again be employing the equation Ohm's law which you call. Then again it will be V by I and this will be 220 again. And incidentally, in the circuit of capacitor as well, you can clearly see in the circuit of element Y, which is a capacitor, again you can see the current flowing is 0.5 ampere. That means the reactance here will again be 440 ohm. You understand? This is the situation now. आपने जब रेजिस्टेंस एंड कैपेसिटेंस दोनों को इकट्ठा ऐड किया है, तो अब आपके पास इन दोनों की वैल्यूज भी हैं, न्यूमेरिकल वैल्यूज. And now if you have to find out what is the current flowing into the circuit, then you see you will have to make the impedance triangle for this particular circuit, and let us make that. If you make the impedance triangle of this series resistor and capacitance, impedance triangle if you are making, then you see that resistance is plotted always on horizontal side. This is the value of resistance which you have already calculated, 440 ohm, and the value of reactance of the capacitor, that is plotted on vertical direction, XC, and this also has been calculated the value 440 ohm. You understand? So the total impedance of the circuit Z, this will be the Pythagoras of these two, isn't it? 440 horizontal, 440 vertical. That means the value of Z will be 440 root 2 ohm, and if you see the phase angle, this is minus 45 degree. Everything you have got. Now if you want the current in the circuit, when you have equivalent resistance and capacitance connected to them, then it will be equal to the same 220 volt upon this 440 root 2 ohm. You understand? 220 volt upon 440 root 2 ohm. This is what you have. And if you calculate, this will come out to be 0.35 ampere approximately. This is the magnitude of the current you have calculated. And if you see here that the Z value is lagging, then that means the current will be leading. Just uska ek reverse hota hai. And anyway you have seen that whenever current is imposed on capacitor dominant circuit, then the current has a tendency to lead. So you can also say that current leads the EMF by 45 degree. You understand? The magnitude of the current is 0.3535 ampere and it will be leading the EMF by 45 degree, and this is the complete answer to your second part of the question. Understand? This is the way you have got the idea of how resistance and capacitance connected in series will be functioning. Now let us take the combination of all three, that means resistor, inductor as well as capacitor, that means series LCR circuit in an alternating EMF source.